Welcome, everyone. Today we're here to talk about one of my favorite things, networking for cloud computing. Today we'll talk about what is BGP. We'll provide a brief cloud networking overview. We'll talk about networking and cloud computing, networking for cloud architects. BGP is an absolutely essential cloud architect technical skill that you must know. And if your net cloud architect training doesn't include BGP, it's not architect training. So we're going to have a lot of fun with it today. Lots of fun talking about AWS BGP and all the great things. Give me a hashtag so I know you're awake. BGP, a hashtag BGP. And the reality is, invite some friends. Take a quick minute, send a tweet, send an email, invite someone. My name is Mike Gibbs. I'm the founder and CEO of GoCloud Careers. I'm one of the original Cisco certified internet experts. In fact, my number is 7417 back when it used to be a 2-day exam. It was so unfriendly and so many people failed it when it was a 2-day exam. Cisco made it a 1-day exam to kind of make it a little easier for people. I love BGP. I've consulted to the world's largest internet service providers. You name a big one, I've consulted to them. And I've helped organizations for more than 25 years with BGP. I was a lead architect at I was a principal 2 architect at Riverstone, a principal architect at Comcast, a lead architect at WorldCom, now Verizon, a lead architect at Cisco, and BGP is just heaven for me. So we're gonna have a ton of fun. I'm gonna put my geek hat on with the propellers on it. We're gonna get a little techie. And of course, we'll talk about the business side, but it's gonna be really, really fun and exciting. Invite a friend. If you don't know BGP, you can't really design anything on the cloud because you need it everywhere. And the reality is, if you're a network engineer, you need BGP. If you're a network architect, you need BGP. If you're a cloud engineer, you need BGP. If you're a cloud architect, you also need BGP. So let's have some fun. We'll present. We'll periodically take breaks so you can all ask questions. For those of you that are on LinkedIn, welcome. Or Twitter, welcome. Or YouTube, welcome. Or Facebook, welcome. We're thrilled to be here with you today. Christopher Johnson, my chief operating officer, is going to go introduce a few concepts, and then I'm going to get fun and get geeky with you. And we're going to talk about BGP, and it's going to be a BGP party.
All right. Well, in case you couldn't tell, Mike is excited about BGP. Mike loves networking. So show Mike some love with that like button on whatever platform you're on. Hit that like button. If you're on a platform that lets you subscribe on like YouTube, hit the subscribe button. Um, that helps us out. That helps spread Mike's knowledge to all of those that can benefit from it. So hit that like button, hit the subscribe button, hit the notification bell button, do all the good things that the algorithm likes. But what I want to do first is I want to let everybody know that we do have the free BGP guide that Mike put together for us. You can get that absolutely for free. The link is going to be in the chat box. I am putting it in the chat box in just a second, and unless someone else already put it there, but you just got it from me. Let me go put it over here on LinkedIn. There we go. Now it's on LinkedIn. So that is the free BGP guide that you can use to go along with this, and make sure you are on top of it. The next thing I want to do is I want to make sure that everybody is aware of our How to Get Your First Cloud Job webinar, or as I like to call it, the How to Become the Ultimate Cloud Architect webinar. That will be this Thursday. That is completely free, where you can come and hear from us about exactly how we train people to become the ultimate cloud architect. You can learn all about our program, all about what it takes to become a cloud architect, absolutely free. Come in and join us on that this Thursday at 1 p.m. Eastern Time. I will put that link in the chat box as well so that everybody has access to that. Completely free, 1 p.m. Eastern Time on Thursday. Last but not least, we decided to start a little bit earlier. We've got our 4th of July promotion going on right now. Right now, you can get 30% off all of our programs except our Elite Cloud Architect program. So 30% off available for the award-winning Cloud Architect Career Development Program training, the Tech Interview Fundamentals training, and all that good stuff. There's the 30% discount is applicable to our payment plans, our payment options. We've got all kinds of payment plans and options available for you. Financing options through companies like PayPal and Klarna and Affirm are available as well on the platform. So let me put that link in the chat box. And then I'm going to hand it back over to Mike for what everybody came here for today, and that is BGP. Oh, Eddie already beat me to that. Eddie got that promotion in the chat box for you. Thank you, Eddie. So, Mike, I'll hand it back over to you. I will disappear. Everybody, I will be behind the scenes here trying to make sure that everything is working like it's supposed to. So don't worry. Mike isn't by himself. If Mike was left by himself, we would never stop talking about BGP. So, Mike, the floor is yours.
Well, welcome everyone. Time for the fun. Time to talk about BGP. In today's discussion, we're going to talk about what is BGP. Then we're going to talk about why do we use BGP. Then we'll discuss how BGP works. And then we'll architect around BGP and do some traffic engineering, which is all kinds of fun. And that's one of the reasons we use it. So what is BGP? BGP is a routing protocol. It's what routers routers use to communicate to each other to find a calculated path through the network. Now, there's lots of ways that routers could actually calculate a path. And there's two kinds of protocols. There's interior gateway protocols, which organizations use inside of their organization. And there's exterior gateway protocols, which organizations use to connect to external entities. So inside of a company, they're probably going to use something like OSPF as their interior gateway protocol, which is what their router used to exchange information inside of their area autonomous system, whichever you want to call it. And when they connect to external organizations like multiple internet service providers or cloud providers, they use BGP. When it comes to routing, there's two ways you can do it: static routing and dynamic routing. In static routing, you tell the router to reach subnet 192.168.1.0, go out this interface. Or to reach subnet 192.168.2.0, go out that interface. And you manually go to the routers and you tell them this. Now, if you only have two routers, that's simple. Tell the router how to go. But I want you to realize that most organizations have 5,000, 10,000, 15,000 routers if they're an enterprise. And imagine going to every single router and putting all their manual routes in. Now, let's say you wanted to hire a monstrous staff of people to literally go from router to router and type in routes. Now, what happens when a link would go down? If you've got 10,000 routers, they'd have to go to all different 10,000 routers and they'd have to reconfigure all the routes. And then the link comes back up and then they'd have to do it. So for those of you that are old enough to remember using a map, where you wanted to go visit your friend, and what you did is you went to a map or a map book, and you looked at the map and you said, take I-95 north for 2 miles, make a right on Gatlin Boulevard and take that for 3.2 miles, make a left on Port St. Lucie Boulevard, make a right on this boulevard. And then all of a sudden, police blocked the road and we were lost and we had no idea where to go. That was the equivalent of static routing. And then we started to use something called a GPS, or a global positioning system. And now I'm on the way to my friend Joey's house and the road's blocked, and it doesn't matter because my GPS recalculates and takes me around another path. Well, that's why we have routing protocols. Routing protocols dynamically auto-adjust. And let's imagine, for example, you have two paths to get to a location. Let me take a little wire. Ordered another Mac Studio yesterday, just showed up. Bought one last year, loved it so much, got a second. Let's say you've got two links, and or three links, better yet, 3 wires, and you want it to self-heal. Without a routing protocol, there's no dynamic route recalculation, which means when something fails, we'd be done. Now, we want our networks to self-heal. We want our systems to be highly available, and that's why we have routing protocols. The routers speak to each other in a routing protocol. They all speak the same language or same protocol, and they exchange their information, and then we know how to go to wherever we need. So if I wanted to go to a website called cindytothecat.com, as soon as my traffic hits the internet, All those routers are exchanging information, and that's how the routers know how to get your traffic to its destination. So every time you go to a website, you're using BGP even though you didn't know it. Once you get off of your local network and you hit the internet, all those internet service providers are using BGP to connect to each other, and that's how I can be sitting here on AT&T and access a website that's in Greece, or a website that's in Dubai that's hosted by a Etisalat, their local internet service provider. And that's how and why these things work. So routing protocols are used to help routers build a map of the network. And when you look in a router, they build something called a routing table. And what it really is here's a subnet, here's the interface to go out. You can think of a router as basically a server with like 50 network cards in it, for example. And something comes in on one subnet, goes out the next subnet based upon the destination. So we'll talk a little bit about BGP before we get into the meat and the substance of it. BGP is a TCP-based routing protocol, which means it's a connection-oriented protocol. BGP is unicast, which is very different than the rest of the routing protocols. The other routing protocols, such as EIGRP or OSPF, they multicast. They say, hey, everybody, I want to speak OSPF. Would you like to become my neighbor? Not BGP. With BGP, I decide I want a neighbor. Sujit, my friend who just happened to see popped up in the chat box, I want to be neighbors with Sujit. I tell my router to peer with Sujit. Sujit tells his router to peer with me. And then we establish a TCP session. So BGP is one of the rare unicast routing protocols. BGP is an exterior gateway protocol, as I mentioned earlier, which means we use it to connect to external entities. So inside of GoCloud Careers, we're going to be using OSPF to route to each other. If I want to connect GoCloud Careers to Verizon and AT&T, like I do, so I have multiple internet service providers. In case one fails, I go out the other one. We use BGP. And I use 3 internet service providers to make sure that we're always online and we've got some of the best routing we need to for our clients. Now, why do we use BGP? It scales. And I mean, it really scales and it is tunable. We're going to have lots of fun with the BGP tuning later today. We have an interior gateway protocol like OSPF. Once we get, say, 10,000 routes into OSPF, that's about all it can handle and it starts to break down. But the internet routing table has over 800,000 routes in it, just IPv4. More than 800,000 IPv4 routes. And if I'm going to connect to 10 different internet service providers, I'm going to get 800,000 plus routes from all 10 different internet service providers. So you can think of that as about 8 million routes on a single router. Highly, highly, highly scalable. Now it's also tunable. With our interior gateway protocols like OSPF, we really can't tell it which things to send and not send. But with BGP, we can. We can say, only send an aggregate route or a summary route, 10.0.0.0/16. Or we can traffic engineer it. We can say traffic should go out this link and come back this link. Or half of your traffic goes out this link and half of your traffic goes out this link. We don't want to have your traffic go out one link and come back. We could make it do that, but when we do that, all kinds of problems occur. And that's called asymmetric routing, and we'll get into that later. But the point is we could tune it to do anything we want. So BGP forms a neighbor relationship based upon you telling it whom to communicate with. Now, how's all this stuff work? Well, we've got to go over some BGP messages. Because if I say to all of you, Posis Asimita, unless you're Greek, you don't know that I asked, how are you today? And the same thing happens with BGP. There's multiple versions of BGP. Each provider, to some degree, has standards that they have to adhere to and may have proprietary tuning. And we need to work these things out before we start doing anything. So there's 4 messages we're going to talk about. We're going to talk about an open message, a keep alive message, and I'll put that into terms that you guys that have more of a cloud or a data center perspective will understand. We'll talk about the update message, and then we'll talk about a notification message. So let's first talk about the open message. Right after the TCP session is established, so router A and router B connect to each other in the TCP process. So as soon as there's a TCP connection between these two routers, each router sends an open message. And that's like, hey, let's start our BGP conversation. And in this open message, the message identifies itself with the BGP and its operational parameters, such as, I'm speaking BGP version 4. You're speaking BGP version 4. Okay, good. The autonomous system number. The way organizations identify themselves on the internet is by an autonomous system number. You have your own autonomous system number if you need one. We'll talk about that later. We cover it much more in that BGP document that I have attached for you. Meaning if you need to connect to external entities, you can apply for a public autonomous system number. A hold time is another thing that we'll see in the open message. What is it? The hold time is the maximum number of seconds that can elapse before the router either needs to receive a keep alive or update message or thinks its neighbor is dead. So what does that mean? Router here, router here. If they don't hear from each other periodically, they don't know that they're alive. Now think about what a load balancer does when it's got multiple servers. How does it work? It runs something called a health check. It's kind of like this. Server 1, are you there? I'm sure here. Server 2, are you there? Okay, I'm here. And then if that's the case and the servers respond, the load balancer will send your traffic to server 1 and 2. But if the load balancer does a health check, server 1, are you there? And gets no response. Server 2, are you there? Yep, I'm here. Server 1, are you there? Nope, no response. Server 2, are you here? I got a response. Server 1, are you there? No response. Server 2, are you there? The load balancer will mark the server as unhealthy and it will shift all traffic to the second server. Well, BGP has something like that. We'll talk about that much more as we get through when we talk about the keep alive. But in that open message, hey guys, let's talk to each other. It's the BGP version number, the autonomous system number, how long we're going to wait for either a keep alive or an update message, as well as the identifier. What's the identifier? It's the name of the router. Now, it's typically an IP address, an IPv4 address, and if you create what's called the loopback address on the router, that will be the BGP identifier, and yes, unless you tell BGP otherwise. But it's kind of like this. I'm Mike. Chris is on the other end of the behind the scenes. If we wanted to form a BGP relationship with each other, I need to know that Chris is Chris. He needs to know that Mike is Mike, and that's all we're talking about. So, first message is an open message. The next message is a keep alive message. I like to think of a keep alive message as a health check. So, router 1's here, router 2's here. Hey, I'm here. Okay, resets the hold time. I'm here. The routers know they exist. Kind of like a health check. Now, if a BGP speaker who's speaking to another BGP router doesn't receive a keep alive in a long time, same way if a load balancer doesn't receive a health check in a long time, BGP knows there's something wrong and it tears down the session because it thinks it doesn't exist. The next message we'll talk about is an update message. Okay, what's an update message? I learned something new. I want to tell you. My wife does this all the time. She goes to a medical conference. My wife's a genius. She's got 170 IQ, and she goes to a conference, and she can remember every single word that the conference presenter said, and she can think in multiple languages. She's pretty cool. But the point is, she goes home from a conference, and she has to update me. Mike, there's a new treatment for diabetes you need to know. Mike, there's a new treatment for this cardiovascular thing, because when we met, we both used to practice internal medicine together. We're both nurse practitioners. So every time she goes to a medical conference, she updates me. Well, in BGP, we've got update messages. What are they? I learned about a new router, a new prefix. Let me tell you about it. And then you can reach it too. That's all an update message is. So the update message is I learned a new route, or a new route went away, and I want to make sure all the routers in the system are synchronized and know this. So that's what we're talking about. Now, in these update messages, what we're exchanging in BGP, they came up with the term network layer reachability information, NLRI. What does it really mean? Here's the route, 172.16.1.0/24. That's network layer reachability information. It's just routing information. Now, when BGP sends the update messages, it'll include certain things. The origin, how did we learn the route? Did we learn it from our EGP, meaning BGP? Did we learn it from our interior gateway protocol, such as OSPF? Or do we not even know how we learned it? Now, when a route passes through an organization, the AS path is added. Every organization in the world that needs to be connected to each other on BGP will have an autonomous system number. So if Chris is autonomous system number 1 and I'm autonomous system number 2, every time Chris sends me a message that he learned, he's going to add his autonomous system number 1, and that's going to give me the path. These are the path attributes. Now, the last part of the update is Chris told me a route went away, and I tell all of you the route went away. Makes sense. We kind of live our lives like this. Okay, so if an open message starts the conversation and a keep alive message keeps the conversation alive, so open starts it, keep alive maintains it, update gives you the information coming and going. The last message we're going to talk about is a notification message. This is not a good thing. A notification message is when something goes wrong. Think about coming home, your wife has an unhappy smile on her face, or your husband, doesn't matter, and you got this look. You can think of that as a notification message. You're already being told something's not good. So a notification message is sent anytime an error is detected, and it will cause the BGP connection essentially to be torn down. So for example, if a BGP version 4 speaker tries to speak with a version 3 speaker, a notification message will be sent because they're speaking the wrong language. Now, unless you're Greek and you didn't get that, it was a completely meaningless message that I sent out there. And that's why we have to speak the same language. Much easier to speak English to an English-speaking person and speaking Spanish to a Spanish-speaking person. That's all we're really talking about, is sending this out. So before we go into the finite state machine, which is really fun, go through these messages one more time. Open, hello, would you like to agree to communicate with each other? Keep alive, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here. Update, I learned some new route. I'm going to tell you about it. I forgot about a route. I'm going to ask you. I lost a route. I'm going to tell you about it. Notification, something went wrong. So kind of keep those in the back of your mind. Now, the next part we're going to get to is going to be a little bit geeky when we start talking about the finite state machine. Then after that, we'll talk about how BGP selects a path, and that's where the fun comes. We're going to do some traffic engineering. It's fun, fun, fun. So anybody have any questions for me? Pop them now. I'll pause for about 5 minutes, answer some questions, and then we're going to get into the fun, the geeky part, where I put my hat with the propellers on. And please make sure you download that book. We can put more training materials in a written material. And we spent a lot of time, effort, and really wanted and hired some really good graphics people to make that book a very valuable resource for you. If you've got some questions, pop them in the chat box, and we'll spend about 5 minutes. And if there's no questions, I'll take that as you guys are completely getting it, and I'll get into the geeky business, and that makes me fun too. Reza, I see you just popped it in the chat box. You're a wonderful student of ours. I'm so excited about your brand new job. Makes me super happy every time one of you guys gets hired. Thanks for popping in, Reza. I'm always thrilled when you're here. Give Chris a minute or two to pop some of these in. BGP book not downloading.
Please send us an email at info@gocloudcareers.net. I will put that in the chat box. If it is not downloading, send us an email.
Richard, what business side needs BGP? Anytime you're going to connect to 2 or more internet service providers and want to load share, you must use BGP. If you're going to have a direct connection to the cloud provider, you must use BGP. If your organization has multiple VPCs or virtual private clouds, you're going to need to use BGP. And because you can't do most of the security things on the cloud that you can do in the data center, it's not uncommon when a company needs security and still desires to use the public cloud to break their system into, say, 1,000 different VPCs. and then they have to use BGP between them. So if you're going to be involved in cloud computing, you're going to need BGP everywhere, assuming you have a direct connection or more than one BGP. What is BGP? Helen, it is a path vector routing protocol that is used to exchange messages or routes in between organizations. BGP stands for Border Gateway Protocol. Now, I'm not one to use acronyms. I'm one to actually use full words. But the sad reality is most people don't actually know BGP by Border Gateway Protocol. They actually know it by the acronym, and that's why I actually use that. What makes BGP handle so many routes? It's the way the protocol was actually architected. So for example, if I have a system that exchanges every little link state in its environment, like OSPF or intermediate systems, and every time something changes, they have to run a full recalculation of the routing table, that's not going to scale. But because BGP is unicast, because the finite state machine is built in a way to do things a little bit slower, it can handle so many more routes. And anytime you make an architectural choice, you're going to have to change things. Look at a tractor trailer versus a race car. The race car is faster off the line, but the tractor trailer can hold more. So it's really about knowing what the point is and why we're using it. But that's the reason. It's been tuned to be a little slower and a lot more scalable. Is BGP too different than IBGP? No, BGP and IBGP are part of the BGP protocol. Here's the difference. eBGP is I'm me, and I connect to the AWS cloud. That's eBGP. IBGP is what I run across my own domain. And actually, if you guys stay around, and we have more than 150 people in this towards the end, and you guys desire, what I will do is I will walk you through ISP scenarios and transit autonomous system scenarios, where we will run BGP and IBGP, eBGP and IBGP. But until then, eBGP is to connect to external entities. IBGP is to take external entities and carry that information across your systems. Great question. Steve C., do you need at least a /24 size network to be advertised? Absolutely not. You may see Google's DNS is 8.8.8.8. Chances are there's a /32 root in BGP that you can find halfway in all the internet routers. So no, not at all. Helen, why is this important as in a solution architect? Well, here's the thing, Helen. IP is the protocol that enables computer 1 to talk to computer 2. If you don't have a network, you can have all the code in the world, all the virtual machines in the world, all the containers in the world, and they will do nothing. So you can think of the network as the foundation to every part of the cloud. And what is the cloud? It's a network in a data center that's been virtualized. No BGP, you've got nothing. How many protocols can a router handle at the same time? It all depends on how much memory and CPU is on there. I've seen plenty of routers that had EIGRP, OSPF, and BGP on the same routers. So BGP is used to connect two networks together, exactly. Are there about 100,000 autonomous systems? I haven't checked recently. We used to only have 65,000, and they just changed the amount of it to up to, so we have many more than them. I'm assuming there's a lot more than 100,000 right now. McB, how do you determine IBGP versus eBGP? If the autonomous system numbers are the same, it's IBGP. 65312, 65312 is autonomous systems connecting together, IBGP. 65312 connecting to 65313, different numbers, eBGP. Now, organizations can choose to use private IP addresses. Private autonomous system numbers in the same manner they can use private IP addresses, or they can reach out to the IANA, the Internet Assigned Numbering Association, and they can justify why they need an external autonomous system number, the same way you would justify why you need a public IP address, and you can get one there. Great question there. Ashke, how learn should the cloud architect learn BGP since they do not learn hands-on? Ashke, you're missing the difference. Here's hands-on. Config T, router BGP, neighbor 192.168, remote AS 653.1.3, network 10.0.0.0, mask 255.255.255.0, neighbor, activate. That's hands-on. That teaches you nothing about design. You actually need to know it 1,000 times deeper, Ashke, to design it than you actually do to configure it. Because if you configure a route on a router in Japan as an engineer, you don't need to know what happens into the rest of the system. You have to understand that if you configure a route on a router in Japan as an architect, what does that do to the voice systems that's sitting in New York City, to the supply chain application that's sitting in Asia, to a messaging app that's sitting in Cape Town, South Africa? And to understand that, SK, you have to understand all the inner workings of BGP. I prepend this AS, what's it going to do? So you need to know it about 10 times deeper as if you were going to do it hands-on. Because in order to design something, it's all about how does it work? How does it work? As opposed to hands-on, which is just doing it, but you may not even know what you're actually doing. I know lots of people that are given commands, but they don't actually know what's happening. And I'll tell you how to learn it, but I want to make it very clear to you. How many of you think you know how the internet works by using your browser? You go to a browser, you type www.cindythecat.com. Now, you know how to use your browser, right? Did you realize your browser your computer first does the DNS lookup, and then the computer looks in its routing table and says, do I have a route to that IP address? Now, do I have a route to the default gateway? Do I have a default gateway? Then your computer sends a packet to the default gateway. Then the default gateway, in order to receive the packet, you have to send an ARP who has the MAC address, and the router proxy ARPs it. And then your packet gets to that router, and then your router looks in its routing table and says, to reach this address, go out this port. Now that may happen on 15 different ports, Ashke, in order to reach the destination. And finally, your packet finally gets to the web server, and the packet is a TCP SYN to open the connection. And the web server acknowledges your connection with an ACK and then sends a SYN back to you. And then you send a SYN ACK, and then you start receiving the data. Did actually using the web browser teach you how any of that worked? No. But in order to understand it, you actually have to read about ARP. You have to read about BGP. You have to read about routers. You have to learn about proxy ARP. You have to learn how TCP sets a connection and all those other things along the way. So there's a big difference between knowing the how-to, which is what an admin does, versus how to performance tune it, which is what an engineer does, versus how to design it, which is what an architect does. And the only way you learn it this deep is you read the specifications for BGP. You read the BGP architecture books, and you study it and you learn it inside and out like the back of your hand. What happens when you go to a website versus how do you put www.cindythecat in your browser? I hope that made sense for you. How many routers can BGP handle, or do you mean how many routes? Right now, we've got routers that take in 800,000 routes or more from 10 different ISPs, and it can handle a lot more than that. All routers are intelligent routers except for the stuff in your home as well. Anything in a business will be intelligent. Multicast would not scale better for an application like this. And multicast would be an absolute security disaster. Imagine connecting on an external network, like an internet point of presence, and connecting to people that you don't want to, and learning routes that you don't want to. BGP must be unicast. It can't be and connection-oriented TCP. It can't be multicast like an interior gateway protocol. But a good question. Mohammed, you are more than welcome. Can I explain how EIGRP can do the work of BGP? It can't do the work of BGP. First, BGP is a standards-based exterior gateway protocol to connect to external entities. EIGRP, you put 800,000 routes in it, your routers will crash reboot and you'll have no network. EIGRP is not meant for anything like that. EIGRP is meant for small networks and it's designed to be simple to use inside of an entity. BGP is designed for big networks, and it has extreme security. It gives you more security. How is external BGP the connection than Direct Connect? Well, actually, if you run a direct connection to the cloud, you can still run BGP if you want to. They just don't force it. Because they assume if you're running a VPN to the cloud, chances are you probably don't have any real cloud needs anyway. But if you're going to be using a direct connection, you need bandwidth. You need things that actually matter. And once it gets into that place, you're going to actually need routing, because if you're going to go to the point of a direct connection, you're probably going to have 2 or 3 or 4 or 10 with VPN backups. Good question though, Kevin. Any lecture coming up on transit gateways? Potentially, but a transit gateway is no different than understanding BGP. And I want to make sure you understand BGP, because if you understand this, you know how to do it on AWS, Azure, Google, OpenStack, Nutanix, Oracle. And you've got a choice. Do I learn how to drive a car? Or do I learn how to get certified and drive a Honda and not know how to drive a Toyota, Mercedes, and then everywhere in between? That's why we focus on the generic piece. How do you design BGP to prevent loops? Well, that's about knowing BGP. That's about knowing how to architect it. All routing protocols can get loops if you're not careful. And that's how the architect designs the BGP. I've seen people do great route reflector designs that have no loops. I've seen people design disaster architectures and they create loops. So is there route redistribution, which can be prone to loops? If so, is there some kind of route map or distribute list or filter to make sure that you're not re-advertising routes? That is a much, much deeper conversation that we can have today. And how to prevent routing loops with multiple routes. I mean, I might need to spend a few hundred hours on that. And the whole point of one of the things they do in the CCI exam is make your systems prone to routing loops to see if you know how to fix them along the way. How often does BGP refresh? It's tunable. There's a default, and then it's tunable. The faster the refresh, the faster you detect timeout errors. The longer the refresh, the more scalable your systems are. So you have to think about these things when you're actually architecting things. Can you use one more BGP connection? That's the whole reason. If you only had one connection, you wouldn't use BGP. You could just use a static route. Does a security architect need BGP? Well, to some degree, yes. And even though the security architect's more focused on security frameworks and training procedures, they're designing security, right? And if you form a BGP neighbor relationship with the wrong individual, you can take in routes. And if you take in routes, it will crash your system and you'll be hacked. So there's encryption that we need to know in BGP, which is not the greatest. There's BGP best practices, which is only accept the route that you think you need to know. There's firewalls involved between ISPs and the cloud or organizations in the cloud. And if the security architect doesn't know enough about BGP, the firewall will break BGP, the entire network will go down, and that won't work out well for the security architect or the business. Now, you won't need to code at all as an architect, but you have to understand the technology. Why is BGP referred to as an application and not solely a routing protocol? It's not. It's called a routing protocol by everybody. What happens is we're getting a lot of people that are not networking people into the cloud, and many of them don't actually know networking. And when they get involved in a routing protocol, they see it as an application, but it's not. It's a routing protocol. And that's the same kind of thing where you see somebody calling like a switch a hub or a switch a router because they don't know the difference. Hi, how BGP works, that's exactly what we're talking about today. And VPN connections, there's a lot of different kinds of VPNs. There's IPsec VPNs, there's frame relay VPNs, there's BGP VPNs. But typically speaking, when most people, there's SSL-based VPNs, but typically when people are thinking about a VPN, they're thinking about an IPsec VPN, where basically you have two routers that connect to each other in the internet, and then they exchange security protocols, and then they tunnel the traffic inside of the IPsec tunnel, and they do things to identify the message that if Chris is here and I here identify that Chris is Chris and he identifies that Mike is Mike. And then on top of that, we use a hashing algorithm to make sure the messages haven't changed along the way. And then on top of that, we sequence our messages so you can't say you didn't send a message after the fact. But we'll be talking a lot more about how BGP works. But we can do one on VPNs if you guys desire another day. Networking, which layer does OSI? Well, it sort of depends. You're going to have a lot of different layers. When we talk about routing protocols, we're talking about mentioning things on layer 3, but the protocol itself and how that works can actually reach the application layer, but that's going to confuse things. So don't worry about that. You need to understand how to architect it as opposed to these kind of things. Is it okay to use a VPN for backup for BGP? VPN isn't a backup for BGP. VPN can be a backup to a private line, but there is no backup to BGP. It's a routing protocol. The key is to have multiple sets of BGP peers. Is BGP a physical machine like a router or software? It is software that sits on all routers that are substantial enough to be used. Why do we have iBGP when we have an IGP protocol? Great question, Gaurav. So let's say I take in 800,000 routes from my internet service provider, and I want to carry that across my network. I have two choices. I can run iBGP across my network, and I learned it via eBGP, and I carry it across my network via iBGP, and then I send it off to another internet service provider, and that works. The alternative is I could take all 800,000 routes that we have, dump them into OSPF, which is our interior gateway protocol, and then put them back into BGP on the other end. The problem is once we get, say, more than 10,000 routes in OSPF, OSPF will crash and fall apart, and everything, our architecture will die, because OSPF can't handle 800,000 routes, but BGP can. So we must use iBGP to carry the BGP routes across the network. And we must use an interior gateway protocol to make the iBGP routers talk to each other. And like I said, if there's more than 150 people at the end of this presentation, I'll do an iBGP thing with you guys. We'll do a workshop and it'll be all kinds of fun. Reggie, how does BGP help with security? Good question. So, Reggie, I've got this special secret electronic device that no one in the world knows about, and no one in the world can get into my house. It's secure. Okay. If you don't have a route to something, you can't reach it. And if you can't reach it, you can't hack it. So one thing that BGP does is it enables you to limit which routes you actually take or send to others, which would not be feasible or possible with other routing protocols. That's how it helps with security. Great question, Reggie. Do we use this to connect to other clouds owned by other companies? We use this to connect to any external vendor. So I want to connect to AT&T and Verizon and load share, I use BGP. I want to connect to the AWS cloud, I use BGP. I want to connect my AWS cloud to my Azure cloud, I use BGP. I have multiple VPCs that I want to peer with each other, I use BGP. We're going to be using BGP everywhere, Michael. And it's a great question. Emmanuel, is networking still a career field to get in now, or is the cloud the way to go? All the cloud is a network and a data center. You can't do anything on the cloud except be a software developer or a database person or an admin if you don't know BGP. You can't be a cloud architect without knowing BGP. You can't be a cloud engineer without knowing BGP. You can't be a cloud networking person without knowing BGP. Truth be told, if you don't know networking, you're going to be a horrible security person either, because you're not going to understand TCP/IP. And if you don't understand TCP/IP, you're not going to be in a position to actually use firewalls, IDS systems, or really lock down something. Now, here's the thing. Cloud is probably a better place to be. But Emmanuel, what you're seeing now is you're seeing people first went to the cloud like crazy. They didn't have the business acumen to know the cloud was going to be more expensive than the data center, but everybody was all cloud. Then people found out the cloud was too expensive and a single cloud would fail. So what you see is now organizations are all building private clouds like Nutanix or OpenStack, and now they're connecting to multiple cloud providers. Single cloud is a single point of failure, and anybody that truly understands networking understands that. So you're going to need networking people. Anytime you're dealing with the cloud, you still need networking people, because the cloud is so weak with networking. It's back to 1998 when it comes to networking. And there's a lot of workarounds in the cloud that require a lot of networking knowledge. So I know people that are getting $400,000 and $500,000 network architect jobs now. And I know cloud architects getting $400,000 and $500,000 architect jobs now, if they've got the right level of business acumen. What do you like to do, Emmanuel? That's always the key. What do you love? That's what you should do. There's plenty of opportunities for both. Are there any other protocols which are alternative to BGP? No. BGP is the only routing protocol that we can use to connect to external entities that has scalability, and it is used everywhere. But great question. How do you combine BGP with a VPN? Well, they're completely unrelated technologies. Here's my private line. I want to exchange messages. I use BGP. Now I've got a VPN tunnel through the internet. I want to use BGP. So I've got now a SASE WAN, a software-defined networking WAN. It doesn't matter. I'm still going to use BGP. BGP is how I exchange routes. A VPN is how I get connectivity. Different technologies, different purposes completely. Steve, path vector, which we're going to get into later, really just means how the paths are changed along the way. That's really all it means. And BGP happens to be a path vector protocol, but it's really an exterior gateway protocol. EIGRP is a Cisco proprietary autonomous system, and BGP is a non-proprietary standards-based protocol to connect to external entities. All in all, the only time you could ever use EIGRP for the most part is on Cisco routers. And the second you use EIGRP, you can no longer work with Juniper routers or anybody else's routers. So even when I worked for Cisco as a lead architect for 10 years, never used EIGRP. EIGRP is the equivalent of AWS's DynamoDB or Amazon's Aurora or anything proprietary where once you use it, you're locked in and you can't work with anybody else. I never use EIGRP because then it prevents people from working with other routers. It's locking them into something that's not good for them, just like using a proprietary database.
All right, Mike. I know you're having fun with all these questions, but I'm pretty sure you got some content to get back to. So I'm gonna make you get back to the content here. But yes, great questions, everybody. Those were really great questions, and I'm sure Mike is going to give us another opportunity to ask questions again.
I sure will.
So
I sure will. Any questions you want, I want to make sure you're great. Please give me a hashtag BGP. And if you haven't liked or subscribed this video, please do so. It'll signal this video to be seen by more people. And we want to help as many people as possible. Not everybody can really afford the kind of training they need. So I want to make sure we give everybody an opportunity to have a better life and a better career. Okay, so now we're going to briefly talk about the finite state machine. A finite state machine is a very simple machine that organizations make where one thing can lead to another thing, which can lead to another thing. It's a mathematics concept. We don't need to get in there. But BGP uses a finite state machine. It's an algorithm that has a set of predefined rules. Now, I'm going to tell you right now, when we talk about this finite state machine, it's going to be the most geeky we're going to get all day. I'm sorry. We have no choice but to do this. Once we get through the geekiness, which is going to be fun anyway if you like networking, not fun if you don't love networking, then from there, we're going to get into traffic engineering, which is the fun part of BGP, which is why we use it in the first place. And while we're at it, if you happen to have the guide that we wrote for you, this is going to be great for you. So go get your guide. The link is in the description below. My team will pop it in the chat box for you. Get your BGP document. We spent a lot of time writing this for you. It's going to be a good reference for your career. So we're going to talk about the states of the finite state machine. We're going to talk about the idle state, the connect state, the active state, the open sent state, the open confirm state, and the established state, which is as good as it's ever going to get. The first state that we deal with BGP is idle. Idle is the initial state. And realistically speaking, the second you've got a router that's been configured for BGP, it's going to reach out to form a TCP connection with another router. But before it does, the router is idle. So you can think of idle as you turned on the engine in your car, you're not in gear, and you're not going anywhere. That's idle. Now, if you just turn on BGP and you see idle, it's expected. It is normal. But if you misconfigured BGP, meaning the network engineer or the network admin configured BGP incorrectly, then you've got a problem. And things will revert to idle, which means they won't actually work. So idle is great if it just started, but if there's a problem, it'll resort back to idle too, and we don't like that. So the next thing that occurs, first we all start out at idle, is the connect state. If router A and router B successfully establish a TCP connection, the router is going to send an open message to its neighbor and transition into the open state. So if all goes well, router A and router B establish their TCP handshake, then router 1 sends an open message to its peer, router 2 sends an open message to its peer, and they both transition to an open send. This is what's supposed to happen. Now, if the TCP session in between the routers doesn't come up, now we've got a problem. And instead of transitioning to open sent, we go to active. Now, what is this active state? Well, in the active state, the router is going to retry connecting. And what's going to happen, if the connect retry timer times out, another attempt will be made. And then the process will stay in connect. But if anything bad happens, meaning we can't establish our TCP connection, open messages don't do what they're supposed to, we go back to idle. Like I said, idle if you just started out, really good. Idle if it's not just starting, you got a problem. The network engineers are going to have to fix it. Active. Okay, I briefly touched this, but we'll talk about it a little more. So if the connect message doesn't immediately connect, these routers go into active. And in this state, BGP will keep retrying to establish a TCP connection. Open a connection. Open a connection. And if the process is successful, guess what's going to happen? We're going to go back to the open sent like I talked about. But again, no TCP connection, lots of problems, back to idle. We don't want to be back at idle unless it's just the beginning. So we talked about open sent. And when does open sent occur? TCP connection is sent. We're in connect state. We send the open message. We're now in open sent because everything went well. This is good. This is the way it's supposed to be, everybody. I said we were going to get a little geeky here. Apologies, but we have no choice. In this sent, after an open message has been sent, the router transitions to open sent. Now, if router 1 is an open sent and router 2 is an open sent, the next thing happens is the routers send a keep alive message to each other. I'm here, are you still here? I'm here, are you still here? That's what's supposed to happen. Now, if the router send a message and there's a problem, a notification message is sent and they go back to idle. Are you sensing a trend? Anything bad happens, they go back to idle. So idle is only normal just in the beginning. Otherwise, any problems, BGP goes back to idle. So all things going good. Router 1, router 2, they started out at idle. They went to the connect state. They both sent an open message. Then They transition to open send. Each router sends a keep alive to each other. You still there? I'm still there. Everybody's still there. Everybody's shaking hands. They're all happy. It's like a party. Now we go to established state, and that's where the magic of BGP happens. But what do you think happens if the TCP connection goes away or it falls apart? Back to idle. You sensing a pattern here? Anything bad goes back to idle. So now we're established. BGP routers, they establish their TCP connection. They're in the connect state. They send an open message. They transition to open send. Keep alives are sent. Now they're established. Now that we've got this established relationship, now it's time to talk. Router A spills the beans on all the routes it knows. Router B spills the beans on all the routes it knows. They're constantly exchanging messages. They're exchanging keep alive messages. I learned a new route. I'm going to tell you about it with an update message. Lost a route. Remove it with a withdrawal message as part of the update. That's the way BGP is supposed to work. All kinds of good stuff. Good stuff. So now you know about the finite state machine. Now, in your book, next we're going to talk about the BGP attributes. In that BGP document we gave you, we got into the real complexities of optional transitive and optional non-transitive and all those other things that I truly want you to know. If we tried to put that in just a BGP session, it would be way too much for the day. So please get that book. I want you to read it 3, 4, 5 times until you get it. I read Bassam Halabi's Internet Routing Architecture book and all of the RFCs from the Internet Engineering Test Course at least a dozen times. Each time I learned something new. 25 years later, I still learn. So never give up on learning. It's an iterative process. Try to get better every day. Now, because we want to talk and get involved in traffic engineering, we have to way to prioritize our traffic. So how do we do that? Well, the good news is BGP has what we used to call in the networking industry a bunch of nerd knobs. What are nerd knobs? We can tune this, tune this, tune this, tune this. Got a friend, Douglas, who's here. He does conferences. You know, when he does a conference, they're dealing with these things that have millions of buttons and slides and dials and things. And he's got the expertise to actually know how to use them. That's serious, heavy-duty audio engineering. Same thing with BGP. I've got 2 links. I want half of my traffic to go out this link and the other half to go out this link. I got to tune some of those knobs. That's where the magic happens. So we're going to use these attributes to actually tune those little nerd knobs. So let's go through what the attributes are. And when we get a BGP message, it's going to tell us about the route. The route went through these different autonomous systems. The route has a local preference of this. The route's origin code is this. And that's what we're going to be talking about next, is the nerd knobs. So that's what we're dealing with. The first one is the origin attribute. Very simple. How'd you learn the route? The origin. Think about it this way. Whenever you hear information, you must consider the source. When I used to practice internal medicine, if the drug company funded a study, I might think the study was biased because the drug company's best interest is to fund a study that's going to make their drug look good. If 2 people give me advice and person A has never done that before, but they're giving me advice anyway, and person B is the world's expert that's already made it to the top, I'm going to take the advice from person B that's the expert, and the person that hasn't gotten there themselves, I'm going to throw that advice away. Well, that's really what we're talking about here, the origin of the route. The route can be learned via a lot of ways. The route can be learned by the routers via the interior gateway protocol, and that's considered preferred. Why is it preferred? If I learn a route that's in my routing table via OSPF under my domain, I believe it more than if I learn some route that somebody else told me about. Makes sense, right? So when it comes to the origin attribute, the interior gateway protocol, which is ours, is highest priority. The second, if we learned it, say, BGP or EGP, is the second priority. The last is when we don't even know how we got the route. Now, how does that occur? Well, either You decided to tune a little nerd knob and deprioritize a route by making it look like you don't know how you got it, or somebody redistributed, say, a connected route or a static route into BGP, and now it becomes incomplete. So, origin code. Interior gateway protocol, 1. Exterior gateway protocol, 2. I don't know how I got it. Oh, that's not believable. But let's think about this. You heard a piece of information, but you don't know where it came from. How believable is that to you? The routers are like people. The AS path. Now, this is going to be fun. We're going to do some AS path prepending. It's going to get exciting and all kinds of fun. That refers to how we learned a route. And what does this mean? Anytime a route comes through different autonomous systems, each one updates the path. So I'll give you an example. Etisalat, which is a great ISP in Dubai, connected to Vodafone, who then connected to Verizon, who then connected to AT&T. Now, if I look at the route in the routing table, I'm going to see the Etisalat autonomous system, then the Orange autonomous system, then I think we said the Verizon autonomous system, and then the AT&T autonomous system. Now, what if the next path is Etisalat, Verizon, and AT&T? In one place, I have to go through 3 entities, and another path, I have to go through 4 entities. Well, which do you think is better? Traverse 3 internet service providers or traverse 4? Chances are it's better for you to go 3. And until proven otherwise, routers prefer the path with the shortest AS path. Okay, you want to get on an airplane, right? I'm in Palm Beach and I want to go to New York. I can take a direct flight. Or I can take a direct flight from Palm Beach to Atlanta, Georgia on Delta, and Delta can get me to New York. Which flight would you prefer? The direct flight or the one with stopovers? That's all we're talking here with path attributes. BGP prefers the more direct path. Now, this next one is really critical. 99% of the BGP things that trick people up are related to the next hop. BGP has what's called the next hop attribute. If in your routing table it says, in order to get to 1.1.1.1, use this place, but you can't reach that place, don't put it in the routing table. So if the next hop is not reachable, the route will not be in the routing table. And it's usually because someone didn't put an interface into the interior gateway protocol or what have you. But the point is, if the next hop is not available, don't go there. Well, let's say I wanted to take my wife to a store. She wanted to buy the world's fluffiest cotton towels that she could find. And I know that they sell them at this store. But my car is broken and I can't drive to the store and it's 100 miles away. Am I getting to the store to go visit those soft, fluffy cotton towels with my wife? No, because the transportation is broken. Well, the next hop in BGP is the equivalent of that car being broken. So kind of think about it. If you can't reach the next destination along the way, don't put it in the routing table. You can't reach it. Wait. Wait was a proprietary attribute created by Cisco. And it was basically this. The higher the weight, the more preferred the path. So I have 2 links to a subnet. Link 1 has a weight of 35,000. Link 2 has a weight of 32,000. Take the path with the highest weight. No big deal. Now, it was Cisco proprietary. Now we have cloud providers like AWS and other organizations that are doing the weight. Okay, so now we're going to talk about the BGP selection process. This is where it gets real fun. And we're going to be doing some, architecture labs. We're going to tune it. We're going to design it. We're going to have fun based upon these things. Here is how BGP selects a path. Prefer the path with the highest weight. Meaning, if all things being equal, take the choice with the highest weight. If the weights are equal, take the path with the highest local preference. If the local preferences are the same, prefer the path that was originated locally on the router. If the local preferences are the same and no route was originated on the router, then take the shortest AS path. And if the AS paths are the same, prefer the router with the lowest origin code, meaning IGP was better than EGP, which is better than incomplete. And if the origin codes are the same, prefer the path with the lowest multi-exit discriminator, otherwise known as MED. And if the MEDs are the same, take the eBGP route over the iBGP route. And if everything else is still equal, prefer the route with the shortest path to the BGP next hop IP address. And this is going to be the lowest interior gateway protocol metric to the next hop. Now, if the routes are still equal, prefer the path that you learned first. Why? It's going to be more stable to keep things and shaking things up and change your BGP routes and recalculate everybody's routes. And if all that's the same, we still need a tiebreaker. Prefer the route that was advertised from the neighbor with the lowest IP address. Now that gets silly. So I'm going to give it to you one more time, and then we're going to get into the fun. Choose the route with the highest weight. If the weights are the same or not set, choose the path with the highest local preference. If that's equal, choose the path that were originated on the router itself. If that's the same, choose the shortest AS path. If that's the same, choose the path with the lowest origin code. If they're the same, choose the path with the lowest MED. If they're the same, take the eBGP route over the iBGP route. If that's the same, take the route with the lowest metric to the next hop IP address. If they're all the same, choose the oldest route. If they're the same after that, choose the path with the lowest router ID. That's how we're going to be dealing with these things. So now we're going to get into some fun stuff. Traffic engineering. I'm going to show you some examples, and then we're going to have some fun and do some together. Now, there's a couple ways we can actually do these things when it comes to traffic engineering. The easiest way to load share traffic is to leak a more specific route on a subnet. So in this particular example, and with BGP, we actually have to advertise routes in both directions. But I want to give you a real simple one here, just showing you a single direction. And then, like I said, in a few minutes, if you guys have enough people here, we are going to go do things together. We'll call it a live lab, and we'll have fun. In this particular environment, we have in our data center the CIDR range of 172.16.0.0/15. For those of you that don't know, please visit our subnetting workshop that we just did. Chris or somebody from my team pop a link to last week's subnetting workshop. But where I'm going to work on the assumption you understand subnetting and supernetting right now, you can see the organization's data center contains the subnets 172.16.0.0 all the way through 172.17.255.255. And that's what we can see inside of this CIDR range. Right now, you can see that on the top link, we told the top router to advertise 172.16.0.0. And we told the bottom router to advertise 172.17.0.0. Now that means the most specific path to reach the 172.16.0.0/16 subnet is the top link. It also means the most specific path to reach the 172.17.0.0 is the bottom link. And if we just put those two routes, we'd be load sharing. 172.16 would go on the top, 172.17 would go on the bottom. Now, everything would work great until we would lose a link, like the top link and the bottom link. And once we would lose a link, let's say we lost the top link, all the traffic for 172.16.0.0/16 would be lost. And that's why we popped a summary address, one that covers 172.16.0.0 and 172.17.0.0. And this is how we have backup and failover. I'm going to show you some of these examples that I've previously drawn. Then we're going to whiteboard it out into a bunch of these together. Now that's by leaking a specific route. Let's do it with a weight instead. If you look in this example, look at what we did. We wanted to send the 172.16 on the top link, and we sent the 172.17 on the bottom link. Remember what we had told you before. We said routers prefer the path with the highest weight, right? So what has the highest weight? The top link has a higher weight of 172.16.0.0 because 35,000 is greater than 32,768, which is the default weight on the Cisco router. And on the bottom link, you can see we changed the weight for the 172.17.0.0/16 subnet. And therefore, we raised that, which has higher priority over the 172.16. So now in this particular environment, the top link will be chosen for 172.16, and the bottom link will be chosen for 172.17. And if either link fails, we've got a backup link. Now let's talk about local preference. Routers prefer the path with the highest local preference, right? So by changing the 172.16.0.0 on top with a higher local preference, and by raising the 172.17.0.0/16 local preference, and by keeping the stock local preference of 100 for the backup links, again, we've got our traffic going out the path that we wanted to, and we're load sharing. Now, if you took something simple like the AWS Advanced Networking, they would tell you to just block one link. But I got to tell you, I've worked in networking for 25 years. If somebody's going to buy a 100 gig network connection or a 10 gig network connection, they're not going to want to sit there and doing nothing. They're going to want to maximize their utilization and performance of their systems. Here we go. Let's prepend the AS path. Remember that I told you that every time a router goes through an autonomous system, it's going to pick up an autonomous system. And the shorter the path, the more preferred the route. So in this particular situation, if you look carefully what we did, the path that the route actually traversed was 64523 as an autonomous system. But you'll notice that we have this second line, AS path 64523, 64523. Note it's the same one. Now that will not happen automatically. When we receive the routes from a neighbor, we can add autonomous system numbers. And what we do is we take the same one that we pass through and we add it multiple times like we did here, because routers prefer the shortest AS path. So in this particular environment, look, the top link is going to be chosen for 172.16.0.0, and the bottom link will be chosen for 172.17.0.0. Now the last one we're going to do, and then after this, we'll get to some questions, and then the lab, we're going to go in there and I'm going to draw some IBGP and EBGP. I'm going to give you a quiz. I'm going to draw links, and you're going to tell me which path is going to be chosen for what. So going back to here, you can see the routers prefer the path with the lowest med. So we took the 172.16, which we desired, reduced the med or the metric of it, or the multi-exit discriminator, changed the 172.17 on the bottom to be lower, and that's how we preferred these links. So let's talk about why we're doing these things real quick, and then I'll answer some questions. Imagine you have two links to your cloud provider or your internet service provider. If you are not careful, what will happen, let's say you've got AT&T and Verizon, and AT&T is 2 milliseconds and Verizon's link is 3, or vice versa. This is what's going to happen. No two links are going to be the same across different carriers. And we're always going to use two ISPs or two different service providers, because if we use two links on AT&T and AT&T has an outage, we can't reach the cloud anymore, or the ISP. So we're never going to be crazy enough to use two of the same links with the same provider. It's like using a single cloud and then they have a network outage and we wonder why all of our systems are knocked down, even though we use multiple availability zones in multiple regions. Nobody for the last 25 years in networking has ever connected more than one link when you've got backup links on the same internet service provider, because the second you do so and they have an outage, you're done. So what would happen if we go out a 2 millisecond link and some of our traffic comes on the 2 millisecond link and some of it comes back on the 3 millisecond link? What happens is we get out of order packets, or data doesn't arrive in order, and that is an absolute nightmare. And that's caused by asymmetric routing. So when we have multiple links on BGP, we have to tell it, use this link up and back, and use this link up and back. And that prevents the asymmetric routing. So we're gonna actually get into some fun stuff. But before we do, I want to make sure there's no questions before we get into the good fun. So I'm going to ask some questions. Let's get your questions answered, and then let's have the party time. I'll draw some things. I'll quiz you guys. You can ask some questions along the way, and we want to make sure everybody understands it. So ask your questions for about 5-10 minutes, and then we'll get into the fun. Do you set up a VPN first and then enable BGP routing protocol? Well, if you're going to use a VPN as your primary connectivity, you would use a VPN. If you were going to use a private line, you would set that up. You can't exchange routes if you don't have a connection, so we always must have layer 3 connectivity before we can ever set up a BGP connection. Good question. Can we use the weight, LP, AS, prepend, med as in-out for manipulation? One, to understand the rule, attributes, and another map. I honestly don't understand what your question is. You can tune the weight. You can prepend AS path. You can tune the med, and you have to do it both inbound and outbound. Douglas has got a great question. His understanding was weight was a unique attribute to Cisco. Does this cause a problem when connecting different vendors? Well, Douglas, not so much, and here's the reason why. When we use weight, it's only for outbound traffic, and it's local to our routers. But if I had a router running Juniper and a router running Cisco connecting to the internet, it would be a problem. Reality is weight's now being supported by other providers, but local preference is something that works on everybody. Multi-exit discriminator works on everybody. AS path works on everybody. I try not to use proprietary tuning things. Good question. So Steve, when it comes to real routers, all routers are going to do multiple routing protocols. So again, what does that mean? It means that we're not going to have a router that can do BGP without an interior gateway protocol, because we need an interior gateway protocol to make iBGP work. So you're never going to find a router that only does BGP. And if you do, don't touch it. You understand the next hop attribute can change to be to another IP address. What situations would call for this? Karen, it's not that you really want to change the next hop to another IP address. It's that if the next hop IP address isn't reachable, then you have a problem. That's really what we're talking about here, Karen, not changing it to another address. Chris, you can go to the next one. Okay. And if there's not a next one, we can get back to the content and have a little fun. I think there's one or two more. Consider this question for a route based on site-to-site VPNs. If your firewall supports BGP and the other side supports BGP4, is routing still possible between the firewall and the VPN tunnel? Well, if you're dealing with something that doesn't support BGP4, don't use it, because BGP4 has been out a very, 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 very long time, and anything that doesn't support it would be something that you don't want to put inside of your network. And you'd have to set it to both versions to BGP v3. But it's a good question. Okay, so we answered some questions here. And like I said, if there was about 150 people, I'd actually start having some fun with you guys. So let's whiteboard a situation. And we'll do some to the internet. We'll do some to the cloud providers. We'll talk about transit. We will have all kinds of fun. So let's do a couple of examples together. I'll draw it up. get over here. You can now see my my fancy drawing board over here. So let's say in this particular environment, I'm going to use a single router to make life easy. Oops, don't know what happened there. Oh, it's Command C, Command V. We've got two routers over here. Now this router is, bear with me a second. Okay, everybody. Do we have internal BGP or do we have external BGP here? Let me know in the chat box. This is internal BGP. And how can we tell? Because we've got the same autonomous systems number, 65312 on both sides. Good. So now we're going to make a minor change. We're going to build on this very rapidly. Now I made a modification. With this new modification that I made, where we have AS65312 connecting to AS65313, is this internal now or is this external BGP now? Good. Now we're dealing with external because our autonomous system numbers are there. And Kisela, we're going to get to your question about BGP mishaps at some point today because that is very critical information. Okay, so now we have it. So now we have an eBGP environment. Good job. While you guys are going to do that, I'm going to have a little fun over here. Okay, now in our environment here where we're going to have a little fun with it, we're going to manipulate things. We have to do this in both directions. Okay, everybody, we're going to see if you guys are getting this. Now, in this particular thing, I advertised the 10.1.0.0 on the top subnet into BGP. And I advertised 10.1.1.0 on the bottom link. That's the way I advertised it. So from the perspective of 65312, right now, it knows to take the top link for 10.1.0.0/24, and it knows to take the bottom link for 10.1.1.0/24. What happens if this link goes down and doesn't exist anymore? Do we have a problem, everyone? And if so, what is the problem? Or did we architect this perfectly? Let me know what you're thinking. Is this a good design or a bad design? Top link goes away. Actually, we lose a path for what? Which subnet becomes unreachable? Karen, it's an instant problem. Claudia, you're right, it's a bad design. Brian, there's no backup path. If we do it this way and the top link physically goes down, we will no longer be able to reach 10.1.0.0/24. So what we have is an actual backup physical connection, but we don't have backups in our routing, which means we can only reach 10.1.1.0/24, which means we lost half of the servers that we might access in the cloud. It's a bad design. Good. You guys, I wanted to make sure you knew that. Now let's say I put an aggregate route on this, 10.1.0.0/23 on the top link, and on the bottom link, let's give myself a little space to do this, I add this link. Now, everybody, which link is going to be preferred right now under healthy circumstances for 10.1.1.0? The top link or the bottom link? For 10.1.1.0, which one is going to be used? Which one has a specific link? The bottom link has a more specific path to 10.1.1.0. The top link has a more specific path to 10.1.0.0. Does that make sense to everybody? So right now, the bottom link is the primary path. Okay, so let's deal with this one more time, since a lot of people didn't get it the first time. Routers prefer the most specific path. Which is a more specific path to 10.1.1.0? Here's 10.1.1.0, or here's 10.1.0.0/23. The most specific path right now is 10.1.1.0. The most specific path for 10.1.0.0 is the top link, because those were the routes that were advertised in the BGP. So we're picking the more specific route. And when you architect a situation, you need to know where your traffic is going to be ahead of time. And you have to design this in your mind. And then you're going to have to tell the engineer, I need you to prepend this, or do this, or do this. That's why we architects aren't touching the tech. We're designing the tech. Because the second we touch the tech, we lose focus of the big picture and we start focusing on the implementation piece. Okay, now, I hope everybody sees this. So right now we see that 10.1.1.0 is preferred on the bottom link. Let's kill the bottom link. Let's shut it down. It's dead. Now where does 10.1.1.0 go? Well, in the top link, you can see we have 10.1.1.0 as the primary. And then we also have this 10.1.0.0/23. Now, 10.1.0.0/23 covers 10.1.0.0 all the way to 10.1.255. I'm sorry, it covers 10.1.1.1.0 and all the way to 10.1.1.255. Does everybody see that from basic subnetting? And by adding a summary route, everything is reachable. Okay, so now let's have a little more fun here. Over here, we're going to have Verizon. Over here, we're going to have AT&T. And over here, we're going to create our own internet service provider. We're going to call it Cindy the Cat's ISP. And she's got a really cute logo. We'll pop them on there. We can have a little bit of fun with Cindy's logo. She's a real sweet, cute little girl. So we've got Cindy the Cat's little logo. We'll pop her in over here. Try and, this is the logo over it. I didn't do that right. Maybe shrink her down real small. So we've got Cindy the Cat's ISP over here. She's here sleeping in her bedroom. Yes, the cat has a separate bedroom that she sleeps on right outside of my office all day when I'm working. So now in this particular environment, what are we going to have inside of our autonomous system? We're going to have a lot of routers, right? Because ISPs basically are just routers connecting to other routers. We've got a router here. We've got a router here. We've got a router here. We're going to have a router here. Cloud providers aren't going to be much different. They're going to have 1,000,001 routers in their environment too. And we're going to have a router that connects to this. A router is going to have a connection over here. The router is going to have a connection here. The router will have a connection here. The router will have a connection here. This is called fully meshed. The router will connect to here. Now, inside of our organization, we have to run a routing protocol. And when it comes to internet service providers, we have two choices. We can use OSPF, which was designed for IP routing, or we can use intermediate systems to intermediate systems, which was actually designed for a protocol called CLNS and CLNP 1,000,001 years ago. It's actually an incredibly scalable routing protocol. But we're going to use OSPF in here, and that's going to be our interior gateway protocol. Now, we're over here, our autonomous system number is going to be, let's see, I'm going to use private ones, not the real ones, 65333. Let's say that it's a private autonomous system number I just picked. Now, we're going to say that Verizon, we're going to give them a private one, 65312. And we're going to give another, we're going to make AT&T's 65312. Sorry, it doesn't matter which numbers we use over here. Now, when I connect to Verizon, they're going to have a router that I connect to. And this router is going to have, say, a 10 gig or 100 gig connection to this router. And I'm going to be running BGP on this router on my connection to Verizon. So when this router in Cindy the Cat's internet service provider connects to Verizon, is that eBGP or iBGP? There's a reason we're building this one at a time. Good job, Carlo and Steve. It's eBGP. And the reason it's eBGP is their autonomous system number is different than ours, and it's an external entity. Now, as it stands right now, this router over here that has the BGP, so as soon as we set up this peering between this router over here, we're going to call it RA. Router A, just to make life simple. Router A just learned 900,000 routes from Verizon. Now, here's something I want you guys to think about. Router B, we're going to give each one of these a letter. Router C, and over here, we're going to have router D delta. So as it stands right now, once we just connected to Verizon, router A has 900,000 routes from Verizon. Now, without IBGP running and just OSPF running, does router B, C, or D know about any of the routes from Verizon? Without IBGP. Make B, you're right. It does not. Claudia, no. Reggie, no. Great job, Reggie. Brian, so the key is right now, the only router that knows about Verizon's routes is router A. Now, if the only connection we have to the internet is router A, we could simply connect router A to Verizon. We could have router A inject a default route into this into our autonomous system. And when cute little Cindy is sitting inside of her PC and her route takes her to router C, and router C has this default route which says 0.0.0.0 unknown, go to router A, Cindy's going to go into her tuna.com website, and she's buying tuna, selling tuna on eBay. She now has a fancy salmon website. She's doing all kinds of great because she's got a default route. And because there's only one internet service provider, it doesn't matter. Now we got this cute little fluffy thing over here, and she wants to start a business selling tuna. Now Cindy's real smart. She found that Taylor Swift loves cats. She found out that Katy Perry loves cats, and she decided to negotiate contracts with both of them. We're now going to both send social media posts to buy Cindy the cat's special shrimp, scallops, tuna, and salmon. This cat has a plan on making a lot of money. Now, Cindy realizes right now that after those both tweet, she's going to get a lot of business. And for some reason, if that one link to Verizon dies, or the Verizon internet service provider has a BGP error on their network, then she's out of business until that gets fixed. Well, let me tell you, Facebook went down because somebody misconfigured BGP because they didn't understand it. The commands are nothing, but it's knowing what to do. The entire Google Cloud was taken down because somebody misconfigured BGP. I've seen outages my entire career because somebody didn't understand BGP. But now, Cisco's got Katy Perry and Taylor Swift. Obviously, she really doesn't, but I know they both love cats, and my wife has taken me to both of these concerts, or she's suggested strongly that I take her, so I've taken her. So I know how much they love their cats. Now we've got Cindy saying, I can't put all my eggs in a single basket. I need two internet service providers. So now Cindy's got two internet service providers. Now with the internet service providers we have right now, router D is connected to the internet. Now everything looks good, right? It does. Now, router D knows all about router AT&T's routes. And router A knows all about Verizon's routes. Tell me in the bottom, does router B or C know anything about any internet routes right now? Nope. Router B doesn't know about Verizon's routes or AT&T's routes. Router C doesn't know about AT&T's routes or Verizon's routes. Not good, huh? No. So if we want router C to know about router A's routes, we have to run IBGP. If we want router B to know about AT&T's routes, we've got to run IBGP. Now, guess what? Router A without IBGP knows about Verizon's routes, but it doesn't know about AT&T's routes. So now remember, Cindy has had this business logic where all of her business goes out Verizon, and she just had a default route. Will that default route still work properly now that we only have one internet service provider? Cindy comes in here, and Cindy's got an Ethernet cable that connects to router C. She's got a default route. Her default route traffic, here's where it's taking her as it stands right now, because that's the only route that's put on the router C's routing table. It goes this way. Traffic comes back. Cindy Bo's tuna goes out this way, comes back. Cindy's buying her tuna. Now Cindy's negotiating in sardines. She found the cat that liked them, so she's doing all this stuff. She's having all this fun. Guess what? This link goes down. Now guess what? Cindy's got a warehouse full of refrigerated cat food, full of tuna, full of salmon, and she can't sell it to anybody because her one link to Verizon is dead. So that's no good. So we'll put the link back. Cindy doesn't like it when she can't make money. Cindy likes the finer things. She likes satin sheets, and no, I'm not joking. And she likes her shrimp, and she gets shrimp and scallops and tuna every single day of the week because she refuses to eat cat food. And she won't even drink out of a bowl. She has a beautiful crystal glass that she likes, and she drinks her water out of a crystal glass. I wish I could say I'm joking, but I'm not. My cat's a little bit of a princess, but we all love her. So now we're going to run BGP between router A, router D, router A, router C, router C, router B, router A, router C. Now everybody's running BGP. Now, right now, some of Cindy's traffic is going to go out Verizon, and some of Cindy's traffic is going to go out AT&T. Right now, Cindy's all kinds of happy because she's got two paths. She can go out Verizon, she can go out AT&T. And now Cindy calls her bestie. She goes out to Taylor Swift. She sends her a text message on Cindy's mobile phone. No, she doesn't have a mobile phone, but let's say she texts Taylor Swift with her mobile phone. Taylor Swift then tweets, "Buy Cindy's cat food. My cat loves it." Now all this traffic comes in. The people that are closer to Verizon come in through Verizon. The people that are closer to AT&T comes into the Cindy's web server. Everything is going great, and it works. Now we've got failover. Now at this point, AT&T's router has told us all of our routes, and now every one of these routers knows the best path. So we no longer need a default route for Cindy's traffic. And here's what I want you to think about. Let's say some traffic is going to be closer to the AT&T. Let's say this is tuna.com. And let's say the users of shrimp.com are actually sitting over here. So what's going to happen is when Cindy wants to reach shrimp.com, because she's got BGP, her traffic's going to go over Verizon. And when she wants to reach tuna.com, she's going to go directly to AT&T. Now, if either one of these things fail, what'll happen is AT&T actually is connected to Verizon, and her traffic will work perfectly. So in this environment, we need our routers to talk to each other and reach each other inside of our autonomous system, which is 65333. And that's why we need BGP, IBGP. And the routers need to reach each other, which is why we have our interior gateway protocol. So that's why we're running BGP. Now, the next thing, and this stuff comes up with cloud computing all of the time. And maybe if you guys want, I'll give you an example of BGP being used to solve cloud computing problems. So I forget what I was thinking about there. So now we understand why we're dealing with this. So now let's talk about this. There's one thing that can happen. If we learn all of AT&T's routes, and we then tell Verizon they can reach AT&T through us, and then we tell Verizon to reach tuna.com, come through us. Does anybody know what happened next? If we do this. So if we take in the routes from AT&T, push them across our network with IBGP, and then tell Verizon they can reach tuna.com through us, how might Verizon's if we were to do this, how might Verizon then reach tuna.com if we told them they can reach it through us? Might all of Verizon's traffic destined for tuna.com come into us and then straight through to AT&T? Does anybody see that being a problem? So this is what we call a transit autonomous system. If I tell you, let's say we've got Chris's cat Sunny, and if Cindy tells me she wants to talk to Sunny, and I get Cindy's routes, and then I give all of Cindy's routes to Chris, and Chris then tells Sunny, his cat, the beautiful orange Maine Coon cat, how to reach Cindy. Sunny's going to reach Cindy through me. And yes, this will come up in all kinds of interviews, especially cloud computing ones and networking. We just became a transit autonomous system. Now, I want you to think about this. Let's say AT&T and Verizon, the bandwidth that they have between all of their networks, let's say these two have 1,000 gigabit per second. Now, let's say I have 10 gigabit connecting me to AT&T and 10 gigabit connecting me to Verizon. We could actually take all of Verizon's traffic through our system, and then we will be what's called DDoSed. It will be so much traffic going through our network that it'll fill up our internet pipes, make our servers go haywire, and we're out of business. Our systems have crashed. Now, if we take in the routes from AT&T and bring it into our autonomous system, and we take in the routes from Verizon, and we don't tell AT&T about Verizon's routes, and we don't tell Verizon about AT&T's routes, guess what happens? Everything is beautiful, and we don't become a transit autonomous system. And okay, so if you're all with me, now where do we see something like this in the cloud computing space? So we see it with VPC peering, VNet peering. If you ever wanted to know why it all starts out, we'll talk about it in a minute. So if you're still here and you're still understanding where we're at, please give me a hashtag BGP. In the chat box so I can see you there. And then we'll get into VPC peering, in which case, before we deal with it, I'll show you a 30-year-old routing technology, and you'll see what the cloud providers have done to work around things. So let's do this. I'm going to do some questions, and then we're going to get into another fun environment. So I want to make sure that nobody gets lost. And then we'll show you some of what the cloud providers are doing with VPC peering, VNet peering, and why BGP is used everywhere. What is the limit of BGP routing? Well, I don't know what you mean by that. We've been using it, and as long as you've got the right routers with the right memory and the right CPUs and good routing protocols, we haven't reached that. Have I ever seen BGP fail? I have seen many, many, many cases. In fact, Kisela, I literally would there was one year where I traveled 200,000 to 300,000 miles in a single year to help people fix their BGP mistakes. Here's where I see most of these networking problems occur. To really master BGP took me 10,000 hours of doing nothing other than just BGP. You'll find, realistically speaking, two kinds of people in networking. There are people, and I've got a lot of them in our organization, that do nothing other than networking. And when we say networking, they focus on just BGP or BGP and OSPF, just routing. I've got a Mark guy that I work with. He's a CCIE. In networking, what did I deal with for the first 10 years of my career? Two routing protocols, PIM and BGP, and nothing else. And when all you do is one thing, you get real good at it. And when all you do is BGP and you live it, eat it, breathe it, and sleep it, and Verizon has these people, and AT&T has these people, every cloud provider has these people, most of them are so good with BGP, they don't make mistakes. Now, I've also worked with this population in networking. They know a little Linux. They know a little Python. They know a little DevOps. They know a little bit of routing. And in the process of, and they know a lot of skills. Those are smart people. But they spread themselves out and to try and learn 4 different people's careers. And in the end, they don't have the 10,000 hours of just BGP. And what they do is the thing that took the BGP cloud down or Facebook down for like a whole day. They make an error, not because they don't know what to configure. It's that they don't have the depth and understanding how things work and why things work. And then they make an error. We see this in cloud computing. Anybody can configure an AWS S3 bucket. I taught a 6-year-old how to do it in less than 5 minutes just because I thought it was fun. And she configured it, and when she was done, she had these pretty little pigtails. She said, S3. It was really exciting. Now, she didn't understand object storage, didn't understand what to do with the metadata, didn't understand how to architect it into a big data environment. She just knew how to click a few buttons and say S3. Well, that's the difference of, and by the way, while we're at it, do you know the largest cause of attacks in the cloud? It's misconfigured AWS object storage buckets or S3 buckets. Not because people didn't take a class which taught them how to click a few buttons in a certification course. That's nothing. They didn't know the why or the what they were doing. And that's why 16% of all hacking attacks occur via AWS S3. Not because AWS S3 is bad, because the people don't know the why. They only know the how. If you don't know the why, you're always going to struggle. Richard, good question. Do we always want all routers to learn all routes? Absolutely not. BGP gives us the ability of tell this router this and this router this. So let's say I'm connecting to AWS. And inside of my network, I've got some top secret servers that are running all these cool intellectual property things. And I'm connected to AWS and Azure. We've got some in our private cloud, say it's a Nutanix cloud, and we connect to AWS and Azure. If I don't want Azure to be able to reach my and AWS to be able to reach my super secret subnet with our fancy servers with all of our intellectual property, with BGP, I don't have to tell them that route. And if they don't have a route, they can't hack it in the first place. It's kind of like this. Here I am just north of Palm Beach, Florida. I got a buddy, Ian. I trained him. He's a great cloud architect. He's working in London. If I want to go visit Ian and I don't have access to an airplane or a boat, I can't swim to him. So I couldn't hack him or visit him in the first place. And with BGP, we actually have the opportunity to choose which routes we send to people by advertising them to them. And by doing so, we've done something extremely magical. We've enhanced our security. With OSPF, we don't have that ability. And that's why we're using a routing protocol like this. Great question. Great question, Richard. So router A, router B, router C, router D all use OSPF. IBGP is used to pass the information, correct, Steve? And the connections, the routers that connect to the ISPs use eBGP, lots of protocols. And yes, Steve, if we're dealing with an internet service provider, let's say we have OSPF internally, And then we might actually use some MPLS for a different type of traffic engineering. And we might signal that MPLS with RSVP signaling to guarantee the bandwidth before we build the session. And then we're going to be switching our MPLS things via TDP or LDP, which is another protocol. And yes, Steve, these protocols go again and again. Steve, for my CCIE, and it was just routing and switching, I had to read 75,000 pages. Compare that to like the AWS Certified Solution Architect Professionals, about 500 pages. So the key is, yes, there's a whole lot to networking. And that 75,000 pages was just routing and switching. It didn't cover wireless. It didn't cover security. It didn't cover voice. It didn't cover load balancers, just routing and switching. But in order to be a great architect, you have to have that level of networking knowledge, not to the level that I'm talking about, but about 10 times deeper than anything that would ever be covered in the AWS Advanced Networking. That doesn't even scratch the surface of an architect's knowledge. Good question. Why not only IBGP for internal routing? Why do we use an interior routing protocol? IBGP can't do interior routing protocol. Okay, for a couple of reasons. So now I want to connect router A to router B. Actually, this is such a good question. I'm going to actually draw it out for you. This is a very great question, Firewall Guy. If my broadcasting software lets me do this. So, great question. So I've got a router over here. I've got a router over here. This is an extremely good question. Now, this router has 4 connections to this router. Let's get one more. So I've got 4 paths on this router. Now we have to be able to manage the routers. And by doing so, we have 2 choices. Now, every one of these links on the top here is going to be on a different subnet. So let's say, for example, here, the top one is on the 172.168.0.0/30 subnet. And that means which we're going to have an IP address on the top link is going to be a .1, 172.16.0.1. And on the far end of this thing, it's going to be a .2. Now the next link, let's say it's 172.16.0.5 and .6. Now we have to be able to reach these routers in order to manage them. We used to use Telnet, now we use SSH. What IP address do we SSH to in the router? What if we decide just to SSH to this link, 172.16.0.1? Let's say we try to SSH to that. And we can. We can secure cell into this router via that IP address. What happens when this link goes down? The IP address is dead and we can no longer manage the router. Now, BGP also needs to form a neighbor adjacency. Now, if we form 4 different adjacent, if the adjacency is on this link and we use these IP addresses, and this link goes down, and all 4 links are on this are off of the 1.1 IP address, again, we're host. So what we're going to do is on these routers, we're going to put a different address on them. It's going to be called the loopback address, which will be used as a router identifier. Say it's 1.1.1.1. Now, if this link goes down, 1.1.1 is still there. If this link goes down, 1.1 is still there. If this link 1.1.1 is still there. But how are we going to reach 1.1.1.1? We need an interior gateway protocol. So that's one of the reasons we need an IGP other than an EGP. Now let's talk about something else. With BGP, if we lose a route, it may take a minute for our routers to be able to do anything about it. It could take a minute from the time we figure it out. And why might it take a minute to find out about a lost route or a bad path with BGP? BGP is designed to scale. It's designed to take in 800,000 routes. Now, we get a cable cut in our internal network and we wait 1 minute for BGP to occur. Think about this. Now, you want to run a 5 nines network, which means 5 minutes unplanned downtime per year. And we have 5 link failures which occur, and they're going to occur a lot more frequently than that in a year. But let's just say we have 5 link failures and all we used is BGP. We couldn't achieve 5 nines availability even if we wanted to, because BGP is slow because it's designed to scale. Likewise, OSPF is fast, fast, fast. So we get a cable cut with OSPF, it reroutes around it real fast. With BGP, it's going to be real slow. So we need something to make our network heal fast. And we need to be able to provide the reachability for our IBGP peers like I just showed you. So we can never get away with an exterior gateway protocol for our internal routing because of the speed that we actually need and the performance that we need. Remember, when you choose scalability, it means slow, 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 slow. When you choose speed, it means not super scalable. Keep that in the back of your mind and you'll be good to go. What are the use cases of IBGP and OSPF? Every time you have a network that has routers, you need to know how to reach everything. And you have a choice, Grace. Let's say you've got 5,000 routers in your network, and each one of them has 8 interfaces. That means your network is going to have 8 times 5,000 or 40,000 routes. Now you can manually go to every router and tell every router about 40,000 routes. IP route 1.1.1.1, next hop, 172.16.1.2. And you can put that in 40,000 times in all 5,000 routers. And anytime a link goes up or down, your traffic isn't going to get to its location, and you're going to have to go to all 40,000 routers and type in all 40,000 commands and new routes. Or you can use an interior gateway protocol like OSPF and let them automatically exchange routing information and self-heal itself. So there's never a time where you're ever going to get away with any network that's got, say, more than 5 routers where you're not going to manually do this. And yes, if you didn't use OSPF, you would have to manually type on every single router that exists how to reach the destination. That's not going to work. That's why we have to use an interior gateway protocol. Why do we use BGP? Well, I gave you an example before, but we use IBGP to take BGP routes across our system. And why do we do that? Because I can't take 800,000 routes from the internet and put it into OSPF. If I do, my router's routing tables will crash, all my routers will die, and then our entire network will disappear. And then every user won't be able to connect to anything. The business will stop making money, and that wouldn't work out real well for the networking or the cloud people's careers. Good question. Does BGP need its own interface? I don't know what you mean by that. BGP needs IP connectivity to work, however that occurs. Meaning you could have a link aggregation group with 4 of them. You could have a single one. Let's get to Samuel Jones. He's making some very dangerous assumptions. For a live video stream, you do not need to use multicast. Now, multicast is optimal for a live video stream. So for example, if I'm a TV company and I've got 100,000 or 1 million users with set-top cable boxes, and I wanted to send it once and have the routers replicate it, I would use multicast, assuming I had complete and total autonomy of the network. Right now, we're doing a live video stream, and we're all doing unicast because there's no way the internet would allow us to route to your houses via IP multicast. We don't have a private network, and we can't run PIM sparse mode or DVMRP across the internet service providers. So keep that in the back of your mind. We have to use whatever is right. Now, on-demand content is typically unicast. Broadcast is often multicast. But what we're doing today is live stream. We can't do that via multicast, so we're doing it via unicast. So for every application, we need to understand the requirements of the application, business requirements, technical requirements, network requirements, application requirements, and all the idiosyncrasies and limitations we have. And how would BGP help you with multicast? Well, let's say you're dealing with multicast, and here's the way multicast works. We've got a video streaming server. and I want to actually subscribe to the video screening server. Here's what happens. I tell the router that I want to watch Cindy the Cat's TV channel. And I do this by sending an IGMP join group message to the router. Now the router sees my IGMP join group message and it says, I don't have it. What do I do? And what it actually does is it sends something called the star comma G, which is an unknown source to the multicast group that I want, upstream to the next router. The next router will see that PIM sparse mode star comma G join, and it will say, do I have it? If it has it, it'll open up its outgoing interface list and send it to the downstream router. If it doesn't have it, what it's going to do is send another star comma G join group to the multicast source. Now, when that star comma G goes to the next router, let's say on that router, it's the rendezvous point and the multicast source is actually there. The next thing that's going to happen is that router will take the outgoing interface that's closest to the receiver, and it will send an S comma G source 172.16.1.0 publishing to group 224.0.0.222, for example. And then that'll send it downstream to the next router that will add a source comma group route in its routing table, open its outgoing interface. And then it'll go to the router where Cindy the Cat is, who requested that stream, and it'll send that source comma group to the router. And then Cindy already subscribed to the stream with the IP IGMP joint group that it did, and now Cindy's watching her TV. And when she doesn't want to see it, that's going to happen. So how does BGP play in here? Well, in order to find the source of your multicast, you need to look up what's called a reverse path tree. And we typically use PIM sparse mode for multicast. And where does PIM sparse mode get its actual routing information to find the source? It looks in the routing table. So inside of our organizations for multicast routing, we use the interior gateway protocols such as OSPF for this. But if we're actually doing interdomain multicast routing, how are we going to get the source of a multicast stream that's not with us? Via multi-protocol BGP. So anytime we want to get a multicast stream, we've got to find the source. And that's how this all works to watch a live stream, like live stream cable TV, for example, or financial feeds, which we typically use in a bank. Now, Samuel James, when we're dealing with the cloud, they don't let us multicast through the cloud, which creates a whole new set of problems. So we typically need to create what's called the GRE tunnel through the cloud and tunnel through the cloud as if the cloud doesn't exist. Richard, I'm so happy you've stayed in this conversation with a sense of comfort and understanding. 3 months ago, I was in the wilderness, then Mike taught this. Hang in there, y'all. Thanks so much, Richard. I always appreciate your super kind words. Richard is a super, super, super impressive person. Why do we need iBGP? Can we use traditional routers internally? Well, not if you want to be able to reach anything that's or carry any BGP routes across your systems. You must run iBGP. You must. Because it goes back to that example I drew you before. I connect to AT&T and take in 900,000 routes. The remaining 3,000 routers in my network have no concept of those routes. I don't know what you mean by its own interface, Steve. Are you referring to an Ethernet card? I don't know what you mean. Now, if you're asking how it's configured, it depends on the router. Most of this stuff is configured via the command line in the routers because it's the fastest way to do it. Now, in today's world, it can also be pushed via an API that's sitting on the routers. Some routers, not your big critical routers, but like your little mini routers, have a web browser interface to them. But, that's the key. It could be, a command line. It could be an API call. There's going to be a lot of different ways. Why can't eBGP used for the internal network? First, it's too slow, and if you use it, you'll have outages and you won't be able to deliver high availability. Secondly, you won't be able to do loopback to loopback connections or have any redundancy in your network because you need to be able to reach certain addresses that don't go down. So you'll have no availability in your systems. Third, it's really slow, and therefore you won't find anything. And secondly, it's not designed to do internet routing. And the only way you could do it would be to have every router in its own autonomous system number. And that would be a complete and total nightmare trying to do it. And you'd manually have to tell every router pretty much about everything. So it doesn't check anything with related to what you would do inside of a network. You need an interior gateway protocol. Like, what's the difference between an intranet and an IGP? Good question. The intranet is all of your own internal network. Like the internet is a public network, the intranet is your private network. Now, in order to make your private network work, you need a routing protocol so you know how to reach it. I might have an accounting system which sits on the network that I want to be able to reach from my desktop. I won't be able to reach it unless we manually put a static route on all the thousands of routers we have or run an interior gateway protocol. So intranet is private. And let's say I've got a data center in New York and I've got a wide area connection to New Jersey, Philadelphia, Boston. It doesn't go to the internet, the traffic, it stays on my private network and is much more secure that way and greater performance. Yeah, there's really no such thing as a BGP interface. That's why I really don't know what you mean. I'm kind of thinking you might be talking about command lines or anything. There's a BGP is a protocol. And it's not a pretty protocol, but it's something that you just have to think about to determine how your traffic is going. And I think if I show you guys the transitive versus non-transitive things that IBGP does, it may help you just a little bit. And I think it'll help you understand some cloud computing things. So let me show you that, and I think we'll close on that. And then we'll take a few minutes, and if any of you guys want to learn how to build an elite cloud computing career, cloud engineer, cloud architect, network engineer, network architect, we're going to hold a session of just career questions. So let me walk you through one more thing. And I think this will make sense to you. Let's get ourselves out of BGP for a little while, and let's talk about VPC peering. So let's say we've got NY. Let's do this. Let's make this Palm Beach. And let's make this one Athens. Athens, Greece, Palm Beach, Florida. I think Tyrone's with us. Tyrone is part of our Go Cloud careers. He's an incredible guy. He's in Cape Town right now. So let's take Cape Town. And I think we actually, while we're at it, I think we have Eddie and Anselm on this call too. And they are all in, Cameroon. So let's do this. And this is going to give you some concept with VPC pairing. So let's say right now, let's get you could get real fancy with Brazil and Colombia, where a lot of our other people are, but let's just keep it, a couple locations. Of course, we've got people spread throughout the US. Right now, IBGP peering is not transitive, which means right now, this is me, Mike, Cindy, and Lisa over here. So Mike, and let's just say Cindy. She's never more than a foot away from me. And over here, we've got Tyrone. This is VPC peering. As it stands right now, VPC peering is not transitive. And what does that mean? It means that I tell Tyrone about my routes, and then Tyrone tries to tell, let's say, Eddie. I tell Tyrone about my routes. Now, Tyrone can reach me, and I can reach Tyrone. Tyrone has a connection to Eddie, but the rules of BGP peering or IBGP peering is I can't tell anybody that's not directly connected to me. So as it stands right now, Eddie, who's over there in Cameroon, can't learn about me in Florida, or it can't learn about because it's there. So this is what's called non-transitive routing. Now, if I want Eddie and Anselm over there in Cameroon to be able to reach me with IBGP, now I need an IBGP peering session between them. Now, Eddie can reach me, and Tyrone can reach me because I've got an IBGP peering session. Now, let's say right now, I have a connection, and who do we have in Athens, Greece? We have my cousin Vigeli. The Vigeli is over there in Athens, Greece. Super nice guy. We call him Lucky. Great guy. Now, Tyrone told me about something, but I'm not allowed to tell it to Vigeli over there in Athens, so Vigeli can't reach Tyrone. Likewise, Eddie told me about something cool over there in Bamenda, Cameroon, and I know about how to reach it, but I can't tell Vigeli over there in Greece. So now we want to get Vigeli to be able to talk to Eddie. Now, Vigeli can reach Eddie through this link. Now, Vigeli can't reach Tyrone in South Africa unless we fully mesh these. And that's what they mean when they say IBGP is non-transitive. Guess what? It's the same thing for BGP. So with IBGP, to make it work, we have two options. We fully mesh them, which is option one. Going to work great, right? It will. What else can we do? Well, let's say for right now, I'm only going to use 3 sets of people right now because it's going to get ugly. Eddie, thanks for your help in the demo. So now let's take this to VPC peering in the cloud. And we have two options with this. Option one is, let's say, Lisa's VPC. When it comes to VPC peering, let's say Lisa has a connection to me and Cindy. Lisa has a connection to Vigeli over there in Greece. And Lisa also has a connection to Tyrone over there in Cape Town. Lisa can talk to me and Cindy. Lisa can talk to Vigeli in Greece. And Lisa can talk to Tyrone. Guess what can't happen? Because the routing of IBGP is not transitive, because VPC peering is also non-transitive, guess what happens? Lisa learns about Cindy's routes and my routes, but she can't tell. She's not allowed to tell her cousin Vigeli over there in actually Megara, Greece, but we'll call it Athens, Greece. And she's not allowed to tell Tyrone about it in Africa. And because Tyrone doesn't know about my routes, Tyrone can't reach me. So we've got a problem. So we can either fully mesh our IBGP peers or fully mesh our VPCs. Or let's say for right now, we're dealing with BGP, not VPC peering. We can turn this router over here into what's called a route reflector. What does that do? It breaks the rules of non-transitive routing. And it now says, hey, if I tell Lisa about my routes and Cindy's routes, she's now allowed to tell Vigeli and Tyrone. Now, Tyrone tells Lisa about her routes, and me and Cindy learn about it. And now when Tyrone's wife makes some super cool dresses, and my wife or Cindy wants to buy a super cool dress from Tyrone's wife, she can go browse the website through Lisa's VPC. So in networking, that's an IBGP, that's called a route reflector. In networking, we have something called the Cloud Hub with AWS if we're going to use VPC. If we're going to use VPNs or if we want to use private lines, we have a transit gateway. And really what that is it's not much different than a 30-some-year-old BGP route reflector. And we're using it to break the rules of transitive routing. And how do we connect with these entities? eBGP. So really what we're talking about is nothing has really changed over the way we've done things for the last 30 years. It's just a matter of where it's at. So let's do this. If you've got any questions or anything you want me to cover, I'll do so now. If not, can you like and subscribe to this video if you enjoyed it? Give me a hashtag BGP, and I'll answer any questions. Then we'll take a few minutes, and then we're going to go answer any questions you have about building a career. We'll break for 15 minutes, and we'll do anything we can to try and give you coaching and guidance so you can have the best career. How does a security group tie into VPC peering? A security group is basically a host-based firewall that you would put inside of anything like a server that says only allow this stuff in. So it's how you would protect, say, certain servers inside of your VPC. Look, if you're doing VPC peering and you're relying on security groups, that's not security. We may want to use some firewalls. We may want to use some access lists, security groups, host-based firewalls, lock down the operating systems on everybody's we're connecting to. But a security group would basically keep someone out of, say, a web server. But we're going to need more than that. A security group is an excellent part of a security architecture, but security is like an onion. Peel back a layer, peel back a layer, peel back a layer, peel back a layer. Great question there, Karen. And I know we got a little geeky going through some of this stuff today, but we had to. But I strongly encourage you to also read the document. This is very, very critical things. We'll answer any questions related to BGP. With transit, though, you still have to manually update the route attachments, or it can also be learned via BGP. No, with transit, you're going to use BGP. In fact, with Transit Gateway or Cloud Hub, you must use eBGP. You're supposed to anyway. You get a little geeky too. I love that. Thank you so much, Leo. Great session. Can we apply a security group at the VPC level? I don't really configure anything firewall guy on. You can put them on lots of different places, whether they be load balancers, whether they be virtual machines. Here's the key. Don't think a security group is going to protect an entire VPC. And if you were to try and do so, you'll be hacked and your replacement will thank you. Security is a big, big thing. For example, with a web DMZ, we might need a network load balancer, a couple of next generation firewalls, another series of network load balancers and next generation firewalls from another company, maybe another series of firewalls and some IDS IPS systems, maybe an access control list to protect the subnet, maybe a security group on the server, maybe on the server itself, a host-based firewall, a host-based IDS system. And then maybe after that, we may have to lock down the server itself and disable unnecessary services, remove some packages, and all those other kinds of things like that. So security is a holistic thing. It's not just any one thing. Geeky is great. Yeah, I'm kind of with you on that. Mick B, thank you, Mike, for the wonderful session on BGP. Thank you so much. Made a mistake and hit the like button. Slap yourself. That's okay. Just click it again. It'll undo it, and then click the like button if you had a good time, and we'll be good to go. When we use a VPN, will we also need to? Well, with the VPN, you actually have the opportunity to configure a static route. But if you're going to use multiple ISPs and have different VPN setup, you might want to use BGP. So I recommend using BGP whenever possible. Can I communicate what is a BGP confederation? I absolutely can. So here's the thing. Remember I told you that when you have IBGP peering, if you don't use a route reflector, everybody needs to be peering with everybody. So let's think about this. The formula to determine the number of IBGP peering sessions or VPC peering sessions as follows. N, which is the number of routers, times n minus 1 divided by 2. So if you've got 3 routers, it's very simple. We've got 3 as the n, multiplied times 3 minus 1, which is 2, which gives us 6, and divided by 3. Life's easy, right? No big deal. We can do our IBGP peering. Now I want you to think about this. Let's say we have 3,000 routers, like an ISP would. We'll have a lot more than that. So we're going to have 3,000 times 3,000 minus 1, which is 2,999, which is going to give us a total of 1 of 3. So, which is going to, hold on, 3, which is going to give us a total of 8.99 million divided by 2. And now we'll have 4,498,500 IBGP connections. So in order to do that, we'd have to have some network engineers go to 3,000 routers and manually configure 4,498,500 routers. So what a confederation really is that it enables us to chop up our autonomous system into multiple smaller autonomous systems. And by doing so let's say we have 3,000 routers and we divided it by 4. So let's think about what that's going to do on the peering connections. It's going to make a big difference. So we have 3,000 divided by 4. Now that means we only have 750 routers inside of each autonomous system. So now we're going to take that, we're going to take 750 times 749, and then we're going to divide that by 2. So now we only have to have 280,875 IBGP peering sessions per environment. So what does this actually look like? With the confederation, what are we actually building here? So here what we do is we take, let's say this entire thing would be our autonomous system. This is really what we own. And let me get rid of the fill. And let's say our autonomous system number is 1, 2, 3, 4. Somebody's got that, so we're just making it as an example. What we might do is inside of our organization create this little private AS 65312, and then we'll turn this one into 65313, and then we'll make this one 65314, and then we'll make this thing 65315. In fact, if you guys want to see why you can't ever have a single cloud provider and ever have high availability, I can show you this for the same reason. So what do we have here? We've got each one of these entities, and they're all separated. They run eBGP between them. And by doing so, we minimize the overhead of the IBGP peering because we have smaller things, and maybe we have some route reflectors and each thing. So that's really what a confederation is. We're chopping our big network into littler networks, and that way we get past the n times n minus 1 divided by 2, and it makes things more scalable. Now let's think about it as a cloud provider. Here's why a single cloud provider is never going to work. Because let's say this is one region. Here's another region. Here's another region. And here's another region. This is why you can't ever have a single cloud and think it's redundant by using multiple regions. Anybody notice something about these regions? See these links? They're all connected to each other. All these things. Now, this region all of a sudden gets some bad routes. Tells the other region. This region gets hit with a DDoS attack and starts sending it over. This region gets some bad networking things and it starts to spread the disease. And what can happen to the control plane, the network, or anything else can take the entire cloud down. And that's why people that know networking wouldn't use a single cloud, because they know where the failures are. We're not gonna cover that too much. For those of you guys that want multi-cloud architecture things and to learn why you can't use a single cloud, we can save that for another day. I'm going to answer a few more questions, then we're going to go straight to your career, but that's the reason why. The network is the common thing between all the regions in some way, shape, or form. Can we communicate B as a subset of NAS to a cloud provider? No. When it's confederations, it's only Muhammad for us to internally reduce our IBGP pairing, but when we connect to others, we always need there. Grace, do we need a wire to connect to the external entity or just code? Well, here, you got a connection. If you don't have a wire between the connections, you can't send any code between them. It's kind of like, let's say I want to call my relative in Greece. I pick up the phone. I call their phone. My phone is connected to my network. Their phone is connected to their network, and the call's routed between us. If my buddy Vigeli, our cousin in Greece, doesn't have a phone, I can't call him. So whether this is a physical wire, whether it's a wireless wire, where we're sending radio waves, whether it's a fiber optic connection where we're using lasers to send photons or light over a cable, or whether it's a physical wire and it's electrons, got to have a way to connect to it. If you can't connect to it, you can't reach anything. And that's what a lot of people don't realize. They think about all their applications, they think about all their code, they forget the network, they don't learn networking, they try to be an architect, and without an understanding of the network, it all falls apart. So yes, networking, and it's a great question you asked, but we can't connect to anybody without a path to it. And the path is some wire or wireless connection. Great question. Next one will be the last one. Igor, what should we use for a health tech? DNS, BGP, all of it. DNS is going to do its own health checks. Your load balancers are going to do their own health checks. Your routing protocols are going to do their own health checks. And even the applications are going to do their own health checks. It's not one, it's all. All of them. Great question, Igor.
All right. Well, that was a great workshop. I'm sorry, I got to cut everybody off here. But Mike, if you would allow me the opportunity to remind everybody of a few things before we jump over to the Q&A session.
Of course.
All right. So first thing that I want to do is I want to remind everybody that we have a webinar this Thursday at 1 p.m. Eastern Time that we would love for you to join us, where we can tell you all about how to get the first cloud architect job and how to become the ultimate cloud architect. We'll tell you all everything you need to know about what it takes to become an architect and how we can help you do so. I'm going to put the link in the chat box here for everybody. And let's see. There it is. It's now in the chat box. And then, of course, I will also want to make sure that everybody is aware of our 4th of July promotion that is currently going on. That is a 30% discount available on our award-winning Cloud Architect Career Development Program and other programs. The only thing it is not eligible on is the Elite Cloud Architect Program, but this is eligible for all payment plans and payment options on all other programs other than that Elite program. So make sure you take advantage of this. I will put the link for this in the chat box as well. And then last but not least, I will put the link to our live stream that will be starting in about 15 minutes or so. Make sure to join us over there to ask all of your cloud career, cloud training questions. We are more than happy to answer those. and look forward to answering those. So, Mike, any last words here for the workshop?
So I know we geeked out a little bit today, but this is one of those critical fundamental skills for cloud architects and cloud engineers. I love doing these things. I love to go meet people. Actually, while we're at it, tell me in the chat box where you're from as we finish. I'm here in Florida. I've seen some of the names. I know you guys are all over the world. And I literally love the thought of knowing that we can use a free platform like YouTube and provide free tech training to anyone in the world. Careers like architecture obviously are far more than tech, but they're business, they're leadership, there are lots of things. But I love coming out here. I love meeting people. Bangalore, India is fantastic. Katy, Texas, Chile, I love that. Did a consulting project in Chile, been to Canada 1,000,001 times. Baltimore via the way of Kenya, I absolutely love that. From Poland, live in UK, London, UK. Absolutely, absolutely love that. Some people from my team are saying that they're getting a lot of phone calls. I promise you, we'll call you back. My team is in the process of doing it, and they'll get back right after the question and answer session or join the question and answer session. We want to help you in any possible way we can. Princeton, Texas. I lived in Princeton, New Jersey. Cairo, Charles in DC. I love that. Ghana. Wow, I give you experiences one day about this physician from Ghana and all the ways he taught me medicine. I learned more things from him in 6 months than I think I did in 7 years of school. It was interesting. I'm so happy to hear that. So thank you all, and look forward to answering your career questions. London, fantastic.
All right. Well, we will see everybody in, let's say, 18 minutes at 5 o'clock Eastern time on that link that I shared in the chat box. I'll share it one last time. There we go. All right. See everybody there. Hope you enjoyed the workshop.